So thanks for joining today. I'm Daryl Price and I've got George Williams with me, and we will go ahead and jump into today's topic. This is the third of three sessions. First one dealt with automate your drawings. Second one, automate the design and sales estimates, so kind of the front to the back. And today we're going to kind of land in the middle there is kind of what's possible and some of the the dynamics of what change can bring to the table when you're working for a company that has the ability to jump into some kind of tool like Ruler. And so George will be speaking a little bit from his background and history and some of the things we'll be talking about there. So, but just jumping into the session, just a quick reminder, we are focusing on design and sales automation out of the things that D3 does. We're looking at workflows, so it really is how to leverage technology where it makes sense. If you have the right kind of product, the right type of atmosphere, sales and design automation can work. And when you bring that to the table along with the other things we do, it really becomes a platform by which we really get to address a company's desires to move forward. And if you bring those things together, tie them together, connect them, integrate them, you really can start to get the insights that companies are looking for as they march forward. So, automation. As I said, if it's the right fit, today we're really focused, on this topic. It's around configured order and engineered order. It's not around made to stock. So we're really focused on that project-centric type of configuration that it's always the same, but it's different, but it's always the same. And when we start looking at Ruler, a quick thing to remind ourselves is it is a platform, it's CAD neutral, so it really can drive a lot of different types of modeling interfaces. So whether that's something on Forge, which is Inventor in the cloud, or whether it's SolidWorks for outputs, both of these we have solutions that are being driven by Ruler, in addition to just Inventor on premise. When you look at what Ruler does, it has three loosely coupled tools. You've got the user interface, you've got the modeler, and you've got the drawing outputs. But today we're really going to stay on that modeler, the black box in the middle that's crunching the outputs. And so what is possible? And so let's look at a couple of things, just kind of catching you up. This is a product where when we brought this into our client's space, the first project before they turned it over to the team, they wanted, how long would this take? And so the team, the guesstimate was somewhere between 12 to 14 hours to do the project. And as you see there, they were able to do that in 3 minutes. So that's a huge gain for them. And a couple of months later, after they got the project in place, got a project in where instead of taking a month and a half to do these columns for an airport down in Florida, they were able to do them all in one day. And you can kind of see their throughput now in terms of being able to process orders. And so the user interface to be able to configure those column covers as well as the drawing outputs. Another, pressure vessels, days down to minutes. And when you start looking at, this is a product that we deliver to pressure vessels and heat exchanger type companies. And when you start looking at the other things, canopies, HVAC, windows, this is the trailer outputs for the SolidWorks modeler, buildings, portable modular buildings, another type of tank or container when you're looking at grain bins, and then of course flat bottom containers for water or petroleum that you might see along the highway near some of your larger companies, and then conveyors as an example. And so that's where we kind of get to where George is and some of his background. And so I want to bring George into the conversation. And George, as you look at the world today and where we've come from, I want to take you back in time when you were with the high troll conveyors. Talk to us a little bit about that background and some of the things that you were faced with as far as challenges, and how did you get to where you are today with Ruler?
Sure. When you think about a product like conveyor, just someone from the outside looking in, it's hard to imagine how much it really varies. And I'm sure those on the call, they can think about similar comments on their product where things need to change by just small increments. But really, you squint your eyes, it's still a conveyor. Well, we had a product that was 10 feet long for one model, one of 160 models, and that one 10-foot section could have over, I think it was 4 billion combinations of bills of materials. Of course, we didn't have all those combinations in ERP, we just did them on the fly manually. And so that was pretty difficult to keep up with. You had to have a lot of product knowledge and understand all of what's going on behind the scenes. And so even to today, and that was 12 years ago for me now, I've been with D3, even to today, conveyor is one of the most varied configurations out there. There's just so much going on with all the different products and configurations. And so, yes, engineering has their designs, yes, sales has their catalog, but if you think about the cost of not doing it, what is that? I know that can be a cliche, but let's look at the sales tool side. Many companies, they may have a spreadsheet or some printer wizard type, you know, choose some options, go next. It doesn't really capture the complexity of these CTO or ETO type solutions. And so we would often get questions or comments from sales like same as except. Well, that's just different, because if we've not done it before and it's same as this old thing, except it's a little different here, a little different there, the whole thing could be different. Especially when you think about the pressure vessels are easy to visualize, because if you change the diameter, some of them change in 1/4 inch increments in diameter, 1/2 inch increments in diameter. Nearly everything changes because of that, in just some slight way. Conveyors, you could have, you know, merges that go in at diagonals, and every roller could be a 1/16 of an inch increment. And as that angle changes, everything changes. So a lot goes on with that. Sometimes it can be difficult for our friends in sales to understand how a minor change really causes cascading changes everywhere else. And it even got to the point sometimes when we would get questions on orders. And it was, can we still do this? Question mark, a literal question mark on an order. That's not the place for questions. That's the place for declaration. It will be this. And so, you know, trying to cut down on that cycle back and forth with sales and the customer on, can we really do this thing or not, was really the goal for us. And so we often look at what's invested in engineering with Inventor and the CAD systems, hundreds of thousands of dollars in some cases, and what's being invested in sales. Excel, maybe some homegrown tool. And so there's not an equal balance there, and sales obviously feeds the engineering team. And so we said, okay, it's time to invest in sales. It's time to take the engineering rules up the stream. But besides just helping the sales team give us good orders, there's a lot of detail that goes into actually producing the designs. And so we saw it as a way that we could augment the engineers, take that repetition away, because none of us went to school or training or whatever to just stretch something a little bit longer or make it just a little bit different than the one that came across our desk yesterday. We want to work on new designs. We want to work on improvements. We want to do changes. We don't want to do that repetitive stuff. The computer is really good at that. So we found a way using these types of tools to automate that repetitive work. And so, you know, I talk about improvements and new designs. A couple of my, I'll call them famous stories, my favorite stories from my hydraulic days. One, we had a hole in a side channel, side of a conveyor, on a curved conveyor that it was missing a hole in this particular size and configuration in the standard drawing, in the CAD, in the CNC file. And so I got called out to the shop, and Harvey in the shop says, you need to put this in your drawing so that we don't have to drill this hole. Every time we get this, we have to drill this hole. And I said, all right, Harvey, how many times do you get this? At least twice a year. He said, okay, well, that's 1,600 next assembly. So how about the next time you see that, you call me and I will come out personally and drill that hole, because it's much less work than to have the engineering team go change 1,600 next assemblies for that one hole. And he said, all right, I'll do it. So sure enough, a few months later, I get a call. I'm in a suit and tie. I get called out to the shop floor, and I drilled that hole because it was less work than having to go into the standard design libraries and put that into all the next assemblies. And so another one was the bearing cost. We came up with a design for a pillow block bearing, a tall one, special design that instead of having channel and a standard pillow block bearing, it was one piece. The net of that was it was going to save us $80,000 a year. We couldn't get to it because of a couple thousand next assemblies that we'd have to go change. And so the backlog in standard design meant that that was 18 months out. So we left $120,000 on the table because we just couldn't update our standard designs. And so when you think about what's happened over the years in CAD and design, we started off with the drafting boards, and then how did people make these changes on the fly? Well, they did a photocopy and they redlined it because that's what all the experienced people would tell us. In my day, we just marked up the designs and went with it, kind of that on-the-fly design. It's great. You got to make a change, or oops, I kind of messed up that on-the-fly design. And then we came up with, all right, well, we're going to help these guys out because we've got this CAD system and we can do these libraries. And we create all these next assembly drawings and everything is beautiful and stitched together. Well, in the end, that created too much overhead in the change management. It was fine when we started, as long as we never made changes to it. But now we want to put that hole in that side channel and we are messed up. And so what if you change the game with these types of tools? And you said, all right, I don't really care anymore about what was built, what was shipped out. I want that for my record. But if I could generate designs on the fly, and the next time maybe that particular configuration was never ordered, it's never generated. Maybe that configuration was never ordered again, then it's never revised. If the rules change or the design changed, it's just as it went out the shop door. But you can always configure or create that particular version with the new rules, or create it from scratch, but you're doing it on the fly rather than having to be held hostage by these libraries and systems that we put in place trying to help ourselves that ended up being too big. Now we've got a way that we can automate this and generate these things on the fly. And so what are some things that,
George, so what was the net impact? We talk about changing it on the fly now with the rules. What was it to make a change like that versus the 100 and some thousand drawings?
Oh, well, yeah, I mean, that's a good point. So the bearing cost, that was a good one. So we implemented that prior to putting in this type of automation system because it's just a timing thing. But in the new system, we would say, thou shalt not use this spacer in this bearing, thou shalt use new bearing. And the next order that comes through gets it. So I can go put that in code, push it out, make sure my tests pass, and if nobody ever orders that design again, and it never gets used. But the very next time that order gets designed, there was a high demand for that type of configuration. Then we would get the new bearing, and the two pieces go away. They're just part of the history of Hytrol. And so it's immediate. And so if you just take that one case, there's $120,000 right there. And for me, when I was in role of director of engineering, that was finally, I was able to have an example to the CFO to tell her why we're spending all this money. Forget about quality, forget about speed, forget about, people can go do these other things at the company rather than just push this hockey puck back and forth. When I said we can implement these fixes and changes and improvements at several orders of magnitude faster than we could ever before, that got her attention because that was a real example of how we had a couple of years prior left $120,000 on the table because we just couldn't get to it because there were other things that were more important from safety, manufacturability, and even cost that we had to put our resources there. And so that is the real selling point here that can sometimes be hard to quantify for folks is what's the value of being able to change and respond to your customers in your industry. And that's really what we're able to do here. And so, with that bearing example, how do we make sure that we're okay? Because if I can make a change so fast, I can make a mess even faster, right? So we have automated testing. Whenever we make these changes, I'm an engineer, I'm not a programmer, right? And so our tools are built to make it very easy on mere mortals like myself, where we can just push the button, send it up to some build server on the Microsoft cloud, and it comes back and says, your 2,000 test cases, 5 of them failed. So I go fix those. And it does that to prevent me from producing a build with known issues that it can't produce something that it should have produced. And so that's a way that we all sleep at night, because these things can be very complicated, because your businesses are very complicated. So if we've got these tests out there to keep us between the ditches, so to speak, then it makes it so that we can have high confidence in the releases that we put out to the shop floor. Because the reality is, it's going to be turned into metal, and the problems are going to show up there. We'd rather have the computer tell us before we are able to push that build out to the production systems for your engineering and sales teams. And along with that, we also have automated revision control, where we can detect whether the file that was produced 5 days ago, 5 minutes ago, 5 months ago is the current up-to-date design. We embed information in it that tells us whether we can reuse that file, or we need to generate a new one, or we need to generate a new part number altogether, including automated part number creation. And so these problems that, over the last 12 plus years, or even back to actual, I guess, date myself, go back to 98. So 21 years of experience here, going through these types of solutions. All these scars on our knuckles, we've automated solutions in place to prevent the pain and try to really solve the core problem here, is being able to respond faster with a lean, mean team, and give high quality to your sales and customers and manufacturing. So I can preach and preach and preach, but that's
Right.
kind of the last 21 years in 10 minutes here.
Talk to us a little bit about, when you think about where Hytrol was competitively in the marketplace, and this kind of goes to the question, you've got the opportunity to automate. Do you make that investment? And if you do, what's the impact? And we saw some of the examples, let's say with the column covers, being able to take 12 to 14 hours down to 3 minutes, 30 columns in one day instead of a month and a half. Tell us a little bit about what the impact was when Hytrol went through that morphine change, and how did that help them in the marketplace?
Well, I will say it's hard to quantify what thing was the improvement that set Hytrol apart, because we took an all of the above approach. We did automation, we did investment in lean, we did investment in machine tools on the shop floor. And the automation was engineering and the front office with the 800 distributors out in the world. And so, there was a balance that we had to do there, because we didn't want to automate everything on the front end, and we're trying to push it through antiquated equipment on the shop floor. When I joined Hytrol, they were using iron workers out there. I was part of the team that said, we need lasers, right? We don't need big Jim, scoring a piece of metal and then changing punches all day long. And so that was part of the solution. And then we had the automation system automatically loading up the lasers. And so it was an all of the above approach. We want to just look at dollars. When I started in Hytrol, and I think it was 2000, to where they are today, it's over 2.5 times the amount of business that they're able to push through there. And so that's quite the improvement over the last 20 or 18 years. So they just keep on going and going, and they're the largest conveyor manufacturer in the country, and they've continued to set themselves apart over the years, because again, they do an all of the above approach. And so some on the call may say, well, I don't have that ability to do all that, but you can be part of the answer to say, hey, we can do this. So we're going to, our part of the system is not going to be the bottleneck anymore. And typically in ETO companies, engineering is always the bottleneck. Well, if you could remove that, what would you be able to do to your business? And so for us at Hytrol, again, it was an all of the above. Now engineering, we always had the spotlight, but I know before we started this, we just want a specific set of numbers here. We had routinely 900 orders in the backlog in engineering. And in the year and a half that we had implemented a system like this, we got it down to less than 40 in backlog. And that's not because the business went away. That's because we were able to automate and push things through and route orders around engineering that had previously gone to engineering, because we have robots automatically processing them, because they were same as except, and the robot was, that's cool, I can do that. And so we just routed it outside of engineering, and we let the engineering team do the truly special stuff, which are the mattress flippers at the end of 2 miles of conveyor. Who knew they wanted to flip a mattress? Okay, we got to figure that out. But the rest of the conveyor, the robot did for us.
Got it. Well, thank you, George, for joining us, and thank you all for joining. as we wrap up today. And if you have questions, if you're wanting to look at where automation can take you and your company, or just some of the benefits that leveraging technology in that workflow and what kind of impact it can make, please reach out to us, D3 Technologies, and we would love to talk to you. And there will be a recording of all 3 sessions going out to all the attendees over the 3 sessions. So look forward to any kind of questions and follow up that you have from that. Thanks a lot.